So now that we know kind of the basics of sequences, that we're really just writing out a list of numbers, we can start talking about, does a sequence increase, does it decrease, and is it monotone? So to start with, a couple definitions here. We're going to say that a sequence is increasing. So a sequence is increasing if S sub n is less than S sub n plus 1 for n greater than or equal to 0. And all this is saying is that the next term, so Sn plus 1 is the next term, is bigger than the previous term. So increasing if the previous term is smaller than the next term. We say that a sequence is non-decreasing if, and all we're going to do now is replace that less than with a less than or equal to. So non-decreasing just means not decreasing, right? It could be all the same, something like that one we've been using, the sequence of 5, that's non-decreasing. It's not increasing, it's not decreasing, it's non-decreasing. We say that a sequence is decreasing if, so now the relation between the two terms, I want the next term to be smaller, so I'll say Sn is greater than Sn plus 1, and we say that a sequence is non-decreasing if, and I'm just going to replace that greater than with the greater than or equal to. So Sn is greater than or equal to Sn plus 1. So this sequence of just 5, it's non-decreasing and it's also non-increasing. There we go. So increasing, they get bigger. Non-increasing just means they don't get smaller. Decreasing, they get smaller. Non-decreasing, they don't increase. There are 3 ways to show decreasing and increasing. And they're very much related, so I'm just going to make a little chart here. So one thing you can do is you can show that Sn is greater than Sn plus 1. For increasing, show that Sn is less than Sn plus 1. You could do that directly, just write out the formula, try to get an inequality. Another way for decreasing is you can show that the ratio of Sn plus 1 to Sn is less than 1. For increasing, I would want this ratio to be greater than 1. So there's way 1, there's way 2, and the last one actually involves Calc 1. Show that the derivative is negative if you want to show it's decreasing. Show that the derivative is positive if you want to show increasing. So I'm going to show you an example of each one of those. And then we're going to determine, does the sequence converge or diverge? If it's increasing, is it increasing to something? Is it decreasing to something? That's kind of the goal. We're always talking about converging and diverge, but to do that, we're going to look at increasing and decreasing. So the question for these next 3 examples are, does the sequence increase or decrease? So the first one that I'm going to look at is the natural log of n. Now what this sequence actually looks like is natural log of 0, which is 1, then natural log of 2, natural log of 3, and it keeps on going. What I want to know is, does this increase or decrease? And the way I'm going to do this is look at a derivative. So I'm going to define a function, f of n, to be natural log of n. So I'm just letting the sequence really be my function. And let's look at the derivative. So the derivative is 1 over n. Derivative of natural log is just 1 over n. If this is less than 0, then my sequence is decreasing. If it's greater than 0, then my sequence is increasing. Remember that n is 1, 2, and it keeps on going. So this is greater than 0. So this sequence is increasing. Next, what I want to do is I want to look at the sequence 1 over n plus 2. And just because I think it's a good habit to write out the first few terms, when n is 1, I get 1/3. When n is 2, I get 1/4, then 1/5, and it keeps on going. I want to know, is this increasing or decreasing? So what I'm going to do here is I'm going to compare Sn to Sn plus 1. That's going to be my goal. So really I'm just comparing 1 over n plus 2 to 1 over n plus 3. So the previous term versus the next term. Well, here's something I know. I know that n plus 2 is definitely less than n plus 3. I think we can all agree on that. And then if I take the reciprocal of both sides, you're going to have to flip that inequality. So now 1 over n plus 2 is greater than 1 over n plus 3. It's kind of like saying, 2 is less than 4, but 1/2 is greater than 1/4, if you want to think of it in terms of numbers. So what this showed me is that Sn is greater than Sn plus 1. So if you go back to our list there, if the next term is getting smaller, that means that my sequence is decreasing. Okay, and the next one that I want to look at, and this is going to be the last one, is the sequence e to the n over n factorial. And when you see factorials, kind of in your head two things. You're thinking ratios or comparisons. Mostly ratios is what we're going to look at. And you might have forgotten what n factorial means. It's like 5 factorial is 5 times 4 times 3 times 2 times 1. You're just multiplying all the way down to 1. I want to know, is this increasing? Is this decreasing? So I'm going to look at Sn plus 1 over Sn. What does that ratio equal? So Sn plus 1, that's e to the n plus 1 over n plus 1 factorial. And this whole thing is being divided by Sn. So e to the n over n factorial. Okay, so when I divide by a fraction, keep in mind that's really flipping it and multiplying straight across. So I'm really multiplying by n factorial over e to the n. I'm going to worry about those factorials just a second. I have e to the n plus 1 over e to the n. Well, the e to the n's cancel, so I'm just left with e. I just need to figure out what is this n factorial over n plus 1 factorial. So I'm looking at something like 5 factorial over 6 factorial. Let's see if we can simplify that. So that looks like 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1. And I think all these cancel except for the 6 on the bottom. So what I'm left with here, still that e, and just n plus 1. Okay? And now you have to decide this fraction, this e over n plus 1, is that greater than 1, less than 1? What is it? Well, think about n getting bigger and bigger. This whole fraction is getting smaller and smaller. So we'll say this is less than 1 whenever n is greater than or equal to 2. So since that ratio was less than 1, that means that our original sequence is decreasing. So there's kind of an example of either a derivative or a ratio or actually doing the arithmetic to show that a sequence is increasing or decreasing.